And please eat. I don't know if I misordered or if they gave me. So anyway, I remember the last time I presented with a beer in my hand, very specifically, it was April 7th in Denver, Colorado. And I know that because it was one, National Beer Day, and two, my mother's 80th birthday. So here's for mom. Next slide. They make us start with this disclaimer slide. If you've been to .conf or you're watching the videos, you'll see pretty much every presenter has a joke he makes about the disclaimer slide. I do not, because I used to have a boss who spent a day with a bunch of SEC lawyers, and even though he was a witness, not a suspect, he said it was not exactly the most comfortable day he ever had. So read the disclaimer and pay attention to it. So next. Agenda. The whole talk is basically going to be about what happens after you ingest the data, after you searched it, and 3 years down the line, you need to refresh your server farm, or you are constantly adding new servers because you can't keep up with the data you're ingesting, these sorts of things. The after day zero, how do I keep this stuff healthy, and how do I make it affordable to run Splunk in the 1, 2, 3, 5 year time frame? Next. A little bit about myself. I've been at NetApp for 6 years. I cover our reseller channel for the Americas, so my territory is Alaska and Argentina. I've been working with Splunk for about 2 years, but this will be my first time with .com. And everybody puts a fun fact on. Mine is, as a hobby, I write economic commentary for a BBC program. So if you're ever interested in what I think about carpenter ants and short sellers, you can Google that. The too long didn't read version is I'm in favor of both. Seriously, I am. All right. So I looked at the 2015 schedule, the agenda for .com, and I went through all of the sessions, and I found a bunch of stuff about how to architect and size your initial deployment, how to build high availability and disaster recovery into your initial deployment, what you can do with the software, even how to manage your config file properly. But nowhere in all of the 2015.com was anybody talking about what is this going to cost me to run in the long term. So that's what prompted me to write this. Also, the other thing that prompted me to put this presentation together is a lot of the solution for this question revolves around storage, and I make my living selling storage. So next. The thing about Splunk is that it's really, really easy to get started. Almost every customer I've ever been to started Splunk with the free license and a handful of servers that they wired together themselves using their internal disk drives. It's easy, it's cheap, it's simple to get started, and it works really, really well when you're in the gigabytes per day range and you're just doing data center monitoring and troubleshooting. The problem comes as you get more and more into Splunk. As you see things like we had last year with Jake, showing how they can use Splunk to find bot networks that are about to launch worldwide spear phishing attacks, and they can shut them down. As you continue to get smarter and smarter with how you use Splunk, you move up this curve, you go from not only increasing the amount of data that you have to deal with every day, you also get into more and more valuable applications. You go from just monitoring your data center and doing troubleshooting up through doing predictive analytics. You start getting in with the business processes and systems. You start spending a lot more time talking to the marketing department about what they can do with the data that you have inside Splunk. And eventually you end up in a place like one of our customers, Ticketmaster, where it's revenue critical for them. They're making $1 million a minute off of their website, and they're using Splunk not only to keep that website up and running, but to also maximize the amount of revenue they can derive off of it. So you've got this problem. It's getting exponentially harder and harder to manage your data, and the data is getting more and more valuable to the business. And nobody talks about that when they're talking about the initial deployment. Anybody from Splunk in the room? I don't recognize. I don't think we have a standard recipe. Okay, I'll tell you something. Splunk actually makes this harder because your typical Splunk rep will go into a customer who's got his 4 servers that he's wired into his rack and say, the hardware doesn't matter, All you have to do is give me this much memory, this many cores, and this many IOPS, and it'll just work. And he's right when you're down here. But what typically happens is over the course of time, as this stuff is getting bigger and more valuable, it gets harder and harder to manage those clusters, harder and harder to keep all of that data available and to keep it in the right tiers. And if you don't look at that when you're planning your initial deployment, in 2 years, 3 years, you're going to be in trouble. How do you know when you're going to be hitting the wall? One of the biggest things is your storage growth is driving your server buys. So you're buying more, Sandy, am I right? You're buying more and more servers, taking up more rack space, more power, and more cooling, and taking on a bigger administrative burden just to get more storage capacity. And what does that mean? It means your CPU utilization on all of those expensive servers is declining. So you have more hardware being less heavily used. Not a good situation to be in, especially with Splunk now saying you need 12 cores by .conf. They're going to be recommending 24 core servers minimum for each one of those indexers. That's going to be a lot of expensive hardware not working all that hard. Oh, the other thing, go back one, please. Go back one, please. The other thing is if you have a server refresh coming. A lot of our business with our larger customers come when they've been 3 years into their Splunk deployment, they've climbed up that curve, so they're now up toward that upper right side, and now all of their servers are out of warranty, and they have to replace the servers and move all the data. You've been there. Next. It used to be about 3 years ago that we would see this happening in 24 to 36 months. I'm actually getting this number from one of Splunk's bigger partners in the Midwest, Kinney Group. And they said 3 years ago, if you've been running Splunk for 24 or 36 months, you were getting to the point where you were becoming what we sometimes call a move-up customer. You know what the problems are, you're wishing you'd listened to this talk 2 years earlier, and now you have a problem. Now, this is happening in like 18 to 24 months. It's happening quicker for two reasons. One, people are just getting a lot smarter about what they can do with Splunk. There are more people who are experienced with it, and there are a lot more use cases telling people what you can do with this if you're doing it right. And that's driving people into that upper right corner much more quickly. What's it going to be like next year? It might be 6 to 12 months. It might be that fast. You go from your little 3 to 4 server starter cluster to something where you're wishing you had paid more attention to how this thing was going to grow over the course of years. I have two customers I can talk about. One is Georgia Tech Research Institute down in Atlanta, a large public research institute. We're trying to get them to let us use their name for .conf. They were so typical. They started with a little cluster. They started with simple monitoring and troubleshooting applications, a few gigabytes a day, and they rapidly grew up to terabytes a day of indexing and petabytes when they started doing a lot of contracting work for the state of Georgia. As the customer said when they came to us looking for a solution, the thing had become a big old pot of spaghetti. They were watching their rack space go up, they were watching management eat more and more of their budget, and they were spending as much time just keeping the cluster running, babysitting, as they were with answering questions with Splunk. Some of the problems, long refill times. If a disk fails, you will know that Splunk writes at least 3 copies of the data every time, spreads it out across disks for reliability. If a disk fails, which they do, especially if you have a bunch of them in a large cluster, you have to rebuild that between the servers over the production network, and it can have a significant impact on the performance of the cluster. Just writing 3 times the data is a problem of itself because nobody wants to be writing. If you're injecting a terabyte a day, you don't want to have to write 3. And it's hard to keep the indexers balanced as Splunk does its load balancing across different indexers. And then you have to worry about the locality of the data as you're doing your search. If the data is local to the processor, you hit performance troubles. So they came to us, actually go back. They came to us after about 3 years And I'll show you the architecture that we put in for them. I'll show you the architecture we also put in with this next use case. This is a Wi-Fi provider out of Texas. They do all the Wi-Fi hotspots for airports, hotels, coffee shops, all of those sorts of things. Again, very typical case, started small, using it just for their doing data center monitoring and also network element monitoring on their Wi-Fi networks. And as it became more and more important to them, they started using Splunk to do revenue optimization through things like ad targeting and that sort of thing. By the time they got into trouble, they had 5 racks of indexers, 100 indexers, each with internal disk drives, and they were simply out of rack space in their data centers. If you've ever worked with a telecom, you know rack space is very, very precious there. And this was horrible for them because Splunk was a revenue generator for them. They wanted to index more, but they didn't have any more space. So we came in, we replaced that 100 indexers with 20 indexers, and we replaced those internal disk drives with centralized storage over fiber channel. And because of the increased I/O that we got out of the fiber channel and the dedicated storage arrays, we were able to break that cycle of just buying more servers in order to support more storage, retire 80% of their servers, and give them better performance, and free up 4 racks to buy more Splunk licenses. So it was a win for everybody. It was a win for them, it was a win for Splunk, it was a win for our partner, and it was a win for us. All because we were able to take the storage out of those indexers and put it onto centralized enterprise arrays where it's much easier to grow and much easier to manage. If you remember when Splunk used to talk about the Bonnie++ IOPS, this one rack of servers and the EF560s that we use, which is my product, had 1.4 million Bonnie++ IOPS out of it. So the thing was a real barn burner. Yeah?
A question on this, if you were just starting a Splunk installation, what would you plan for storage at the beginning? Meaning, would you over-provision at the start, or would you plan on some amount per year and then incrementally provision?
Did everybody hear the question? Okay. Who asked a question of Jake last month, and Jake's answer was, I'm an engineer. You know the answer is it depends. It depends. It depends on how much data that you are indexing, how long you want to retain it, how long you want to have it on the hot and the warm tier, how long you want to archive your cold tier. So there's no generic answer to that. I would say there are, and I'll get to this in a couple of slides, there are ways of architecting the hardware up front so it's easier to expand it and easier to grow it, and the incremental expense for doing it that way versus just putting a few racks in a few servers in a rack is not that much. So my point, and again, I'm selling, right? But my point is that it's going to be worth doing this up front, especially if you think Splunk is going to grow quickly and become a business critical part of your organization. Does that make sense?
What is EF560 and how does it provide the ultra low performance?
Okay, so I think you came in late, which is fine. Go get a burrito. Somebody hand this guy a burrito. I work for NetApp. We are a data storage company. Our biggest competitor is EMC, and most people have heard of them or heard of us. We are not sensitive about that. The EF560 is one of our products. It is small. It is a 2U box with 24 drives in it, all flash. That's part of where the speed comes from. But I should point out, these were all flash also. These were all SSDs in here. So it wasn't like we were going from rotational to all flash, and that's how it got so much faster. Right? It was SSDs on both sides. I have some slides about the entire ESeries line in a couple of slides. Okay. All right, here, have a pen. The other thing about this, because of the title of this is managing for the long term, typically successful Splunk implementations, and this is one, will grow anywhere from 40 to 80% year over year. So you start with 100 servers, in the next year you have 140, it grows up for that. In 4 years, when it's time to replace all of these, you're going to be up around 200, 250 servers, right? All with data embedded inside of each server. And now it comes time to retire those servers and replace them. It is a pain in the butt at this scale to do that kind of migration. Splunk actually makes the data management fairly easy. You can just put the new servers in, turn them on, point the hot indexers to those, and let it, over time, just kind of rebalance it. But at this kind of scale, that's a pain. Even as easy as Splunk makes it in the software, it still takes a long time. With this, the data stays on the storage arrays, and you just replace the servers. It's much, much simpler. One thing about data management that is very different from virtual machines or virtual networking is that data has weight. If you're doing virtual machines and a virtual CPU executes an instruction, you don't care where it was executed. As soon as it's done executing, you don't care what happens to it. You don't care what happens to that virtual machine. Same thing with packets going across a network. As soon as the packet gets to the other side, you don't care anymore. The data, you care about forever. And that makes migrating the data, archiving the data, and that sort of thing a lot harder than just managing the computer of the network. So migration best practices. Both in the unnamed Wi-Fi case, they saw it coming. They knew that they were constantly buying more servers every several months, and they did not wait until they had a crisis to make the migration. And in that case, it was actually fairly simple. You put in the new storage, you put in the new servers, you configure Splunk to start using that for the hot, and you just wait. As long as you have time, that's fairly easy. The GTRI example, they kind of waited a little too long, and it was a scramble to get everything moved over as they made the transition. So the first thing is, watch what's happening on your Splunk cluster, and watch as you're moving up this curve, and make sure that when you get close to that wall, you have a plan for doing your migration. Or, if you're starting Splunk now, start with something that's going to be easier to grow and never hit that wall in the first place. A lot of Splunk implementations, almost all of them at the beginning, start with direct attached storage. Either internal disk drives in the servers themselves or DAS external to the server boxes. In our smaller configurations, we'll do that. You can hook our ESeries directly into the servers using SAS. And for small implementations, that's inexpensive and very high performance. But for larger implementations, we suggest you move to Fiber Channel. And that's because Fiber Channel is going to give you a better fan-out ratio. How many servers can you hook up to a particular array so that you can balance and optimize how much storage you have, how much versus how much compute. It's going to be easier to manage in the long run, and the performance impact is negligible. The other thing to think about if you're doing this migration is what are you going to do with all that new rack space? Right? The kinds of results that we get, you saw in the Wi-Fi example, that was an 80% reduction in rack space and servers required. And it was faster. It was 5 to 6 times faster, and that's a difference of seconds versus minutes for some of their queries. Of course, they're doing very large data sets when they're doing the queries, so they're a little bit on the right-hand side of the curve. Better reliability and performance under failure. When you have hundreds of servers, each one with 12 to 24 drives in it, you are going to have disk drive failures almost constantly. And every time you have a disk drive failure, Splunk has to rebuild and rebalance. And that doesn't happen with us. If you have a disk drive failure, Splunk never even notices. A light turns red on one of our drives. If you're hooked up to our auto support phone home feature, we'll actually mail you another drive. You'll come in one day, there'll be a box there. You just take the drive out, you pull the one with the red light, you put it in one with it, it'll have a green light. Splunk never even notices. And most importantly, for larger customers, now you get to scale your processors and your storage independently, so you're not buying a lot of expensive 24-core servers just to get more storage. Does this make sense to everybody all right? Remember, I'm going to be standing up in front of a bunch of people in Orlando, so am I on base? Is this, I've noticed some heads nodding.
Look at the example, we say 3 times, right? So, so then that would be for cluster investors, but not for unclustered.
I think it's for both. Yeah. Oh, okay. And actually, that's the minimum. Depending on how much more bandwidth you need for doing searches, you might have to write even more. So, here, somebody get back on the pen. These are laser pens. And they have warning labels, so if you put somebody's eye out, it's not my fault. Next. All right, so this answers your question. What the heck is the ESeries? It's basically an enterprise storage array. It's like EMC, VNX, VNXE, it's like our FastBox. It has a couple of features that actually it lacks a couple of features that makes it more interesting in this space. Somebody was talking about buzzword compliant earlier. We are not buzzword compliant. We don't do compression. We don't do deduplication. You don't need those for Splunk. Splunk's already doing compression. And if you have a unique time code on every line of your log, there's not a whole lot of deduplication to do. One reason we are so fast, we can do that 1.5 million body plus IOPS, is the operating system that runs inside of these things is very, very highly optimized, not for doing a lot of data management features like dedupe and compression. It's highly optimized for being fast, low latency, and getting the data from the network to the disk as quickly as possible. And you can see some of the numbers that we have here. We just came out with the 2800. Actually, it'll be announced next week. 300,000 IOPS in a 2U box. The EF560, the all-flash version, 2U. And we can get 825,000 IOPS in 2U. We have the 2 controllers, the 2000 and the 5000 series. We have 4 disk shelves. What this does is it lets you mix and match the performance of the controller and the capacity of the disk shelves so that you can get the right balance of the speed you need for the indexers and the density that you need for the cold storage for the long-term archives. And you can do it in one architecture. Other enterprise vendors who offer these kinds of solutions, they have at least 2, possibly 3 different architectures. You know, a dedicated all-flash tier for the hot warm, a different rotational tier for the cold. It's more complicated, it's more stuff to manage, and it's more moving the data back and forth over that network. We have another thing called T10 Pi. One of the engineers made me put this in. This is what the actual important part is. BER, bit error rate. When you write to a disk drive, even an SSD, it doesn't always write what you told it to write. And the error rates for commodity drives, like in your laptops, it's 1 sector for about every 10 to the 14th bits. For enterprise drives like we use, it's 1 to 10 to the 16th bits. That means that you're going to have 1 bad sector for every 62 terabyte drives that you have in your system. Will you ever find that? Maybe not, right? You're archiving a lot of data. You're never looking at it after it's been written. It can sit there for years and nobody will ever notice it. But one day you're going to hit one of those bad sectors, and we don't know what the results are going to be because we don't know how critical the data that was corrupted was. T10 Pi is basically the iSCSI protocol extended to provide data protection all the way from the application down to the platter, so that you know what you intended to write is what actually was written, and 2 years later when you read it, what you read is what was written. That's very nice. This other one, this is more practical. You know, in enterprise arrays, we typically use RAID, redundant array with expensive disks, to provide data protection so that when a disk fails, you don't have to do a software rebuild. These RAID levels have been around for 20 or 30 years. They work very well, but they have a performance impact as your drives get bigger. If a 4 terabyte drive fails and you have to rebuild it by copying the data onto a spare, you're limited by how fast you can write to that single spare drive. We use something called dynamic disk pools, where instead of having a single spare drive that is the bottleneck that throttles your performance on the rebuild, we spread the rebuild across all the drives in the array. So we can take a 4 terabyte drive and rebuild it in a matter of minutes rather than a matter of hours. That's a performance increase, but more importantly, especially when you have a large number of drives, it's a reliability increase, because if you have another drive failure during this time, that can actually cause you to lose data. So we're shrinking the window of vulnerability there. And if you configure that 4U, that 4U disk drive chassis correctly, we can actually set that up with DDP such that you could lose an entire tray of drives and the array would still keep on and you would not lose data. Go ahead. Go ahead. Like every Splunk vendor, we have plugins and apps for all of our. Oh, come on. I don't, but I don't know any. Oh, every lobby user. Yep. Yeah. We're good. All right, come on.
Thank you.
Yeah, we're good.
Thank you.
Sorry.
Excuse me, you expecting more people?
Probably not at this point. We're probably good.
That's it?
Well,
While you did the phone number for you or something?
I'll come around, sorry.
Please. Sorry about that.
I'll start over. We have apps for all of our different products so that you can plug us in and manage us with Splunk. You know, that's table stakes for dealing in this ecosystem. Next. Oh, I should go back one. There is one thing I don't think I mentioned yet, and that's encrypting data at rest. This is really important because the Splunk data, a lot of big data type, Splunk, Hadoop, the data itself is human readable. And it's just in blocks that if you hook that drive up to any Linux box, you can read. So we've had instances in customers where people have stolen drives out of their Hadoop cluster, walked off with $10,000 or $100,000 worth of stolen medical records. We can do data encryption at rest so that when you pull the disk at no performance penalty. So at line speed, we encrypt all the data on the disk. If somebody walks out with that disk, it's useless to them. Okay. Next. So I'm just going to real quickly wrap this up by walking through some of our performance characteristics. This is some testing we did, apples to apples, with Dell servers with internal disk drives. Then we took the disk drives out, hooked them up to the ESeries, and ran the performance tests again. I would be showing these if we weren't better. For indexing, you know, it's kind of a wash because indexing tends to be more CPU intensive than IO intensive. So for the indexers, you don't get that much of a performance. It's the search that starts getting interesting. This is static search results ranging from dense events to sparse events. We're always better. The sparser the data gets, the sparser the events you're searching for get, the better our performance is. And when you start looking at streaming searches, it gets even more dramatic. The reason for this, the difference between the dense and the sparse results, how much faster we are, is that with dense events, you know, these are things like logins on your web servers and those sorts of things. When you have a pile of needles, you don't have to search that hard to get the needles. The hard part is organizing them so that they make sense. That's CPU intensive. When you're looking for a needle in a haystack and you have to go through every block to search for that needle, that's where the IO improvements that we have come in. So you'll see for the orange line is internal disk drives. Your performance varies widely depending on how dense the events you're searching for are. With us, it's dead flat. You get the same performance just searching for error versus searching for, 10 minutes later, something very, very specific that's going to tell you what's going on your network. Next. Okay. We've been working with, yeah.
Data, what about you comparison with like aggregating physical information? So like aggregating like kind of metrics for CPUs, things for health versus aggregating all those things like that.
I don't think we've tested that. Yep. We've been working with Splunk to try to make this easier to buy. We have a bunch of different bundled solutions that are available through our partners. The last thing I wanted to talk about, this is my last substantive slide, is what's happening with storage now. I'm talking about managing data for the long term, and storage technology is changing faster right now than it has in my entire time in this industry. One of the biggest things driving this is that NetApp and EMC are no longer the biggest buyers of disk drives in the world. All of the biggest purchasers of disk drives are the hyperscalers, Facebook, Amazon, eBay, those guys. And that means the drive manufacturers are designing their next generation for the hyperscalers, not for enterprise arrays. And that's forcing us to change a lot of how we manage the data on the disks and also how we design our products. One of the big trends right now is moving to very high rotation capacity rotational drives that have limited writes. You might only be able to write a sector 4 times before it's done, and they're very, very slow. So these will be great for long-term archives. Some of them will even power off after a certain period, so you're not paying to power and cool them. But if one of them fails, that rebuild time can be horrible. The other thing that's happening on the other end, on the performance end, is massive SSDs. Samsung already has a 15 terabyte SSD drive. We're going to be shipping those later this fall. Today, they're expensive and power hungry, but they're getting better faster than Moore's law. So if it's 15 terabytes today, in a year it's going to be 30, 2 years it's going to be 60 terabytes. Remember that 4U disk shelf I showed you with 60 drives in it? You'll be able to get almost 4 petabytes of SSDs, raw capacity, in 4U. Yeah. You might look at this and think, wow, this is great. This is going to solve all my storage problems because it's going to be, pennies a gigabyte, everything's on SSD, and I won't ever have to worry about sizing my hot versus my warm versus my cold again. It's true, this is going to be a lot easier to manage a lot of things, but it's going to make it easier and cheaper to index everything, except for the Splunk license. And Sandy had this talk 2 months ago. That's his presentation. But the things you're going to have to worry about, especially if you're in that homebrew server cluster with the internal disk drives, what happens when you have to rebuild a 60 terabyte drive over a 40 gigabit Ethernet? It'll take days, even weeks, to do those rebuilds if you're doing it over the internet. Do you really want to do that with a 50 or 60 terabyte drive? At this point, I think the homebrew server cluster is going to be a less attractive starting point, or you're going to start going into some new technology that's coming out from Intel that lets you put a lot of flash in the server itself, so your hot and your warm never leaves the server, but the cold ends up on one of these big, slow rotational drives. Next. If you go to NetApp.com, search for Splunk, you'll find a whole bunch of great stuff. Next. Summary, plan for success. When Splunk is successful, it grows like wildfire. If you don't get ahead of that, you're going to end up in a lot of trouble in 2 years, maybe even less, as you have to do the migrations that I've described with people like GTRI or the Wi-Fi customer. When you are all the way up here, like at Splunk Live in Boston, I saw a really great presentation from the business analytics guy at Dunkin' Donuts. He runs Splunk for everything, and he's actually paid by the marketing department. Because what they found when they started implementing Splunk just to manage their data centers is that the marketing department would call them saying, we want to know what happened at this particular point with our pumpkin donut promotion. And he would have to pull an engineer off and have that engineer spend 3 days digging through log files to try to figure out what was going on. With Splunk, they got that down to 5 minutes, and then he decided, I can just implement a self-serve portal, and they don't even have to call me. They can answer all these questions themselves. That's when Splunk became revenue critical for Dunkin' Donuts. Now imagine this guy when they come to him and say, well, can you start indexing this? Can you start running reports or streaming searches on that? And he has to say no. I'm out of indexing capacity. I'm out of search capacity. I don't have any more rack space. When marketing is paying your salary, you don't want to be in the business of saying no to them. So planning ahead, an ounce of prevention is always worth a pound of cure. Small clusters are easy at the beginning. You can outgrow them. And enterprise storage arrays, whether it's from us or one of our competitors, are a great way to avoid running into that wall. And that's it. Yeah.
So how would you compare your fastest solution to some PCI connected EMLCs such as Fusion IO?
So EMLC is one of
the part of the question is you showed some graphs with the really high threads and low for our favorite. What is your secret sauce? So
EMLC is one of those memory technologies that I mentioned, like Intel, what Crosspoint and others, where you put very, very fast persistent memory, dense persistent memory right where the server. So that's kind of what I was talking about at the end, where maybe we get to the point where your hot and your warm never leaves the server, and then you just archive it off to big, slow rotational disks that you only get to write 4 times. Make sense?
Yes, absolutely. So my question before, how does it compare these solutions you provide really high number of IOPS, because that's what is important, I think. Yeah. Not how much you can transfer one pipe, but the actual IOPS. How do they compare to some of the players out there?
So I don't run into Fusion IO or the other ones right now all that often. My big competitor is white box. So enterprise servers with internal disk. No, we just don't see them that often. It's not a very common way to deploy right now. I think in a couple of years that's going to change. But for right now, it seems to be a world of internal disks versus centralized storage.
You never really compare to IO or other PCI.
No.
Whatever their IOPS are.
Yeah. I mean, they're going to be faster, right? Because they're sitting
more expensive, probably.
But they're going to be faster. They're more expensive. And the one thing that happens is you get the same kind of locality problems with the data that you have with internal disk drives. So only one particular server can search the data that's stored on that PCM, that PCI card, as opposed to us where it's equal access for all of the servers. The other question you asked was, why are we so fast? Basically, it's because we were designed only to be fast, right? If you look at our other major product line, ONTAP, it has a lot of features which in what IDC calls second platform applications, VMware, Oracle, databases, web and app servers, that kind of thing. You want deduplication, you want snapshots, you want all of this other data management stuff. In Splunk, in Hadoop, NoSQL databases, that stuff just gets in the way because all of that data management is built into the application layer. Because they all came out of the hyperscalers, and the hyperscalers did not want to tie themselves to a particular hardware vendor for any part of their architecture. They moved all the value of things like flash copy out of the array and put it in the application layer. We don't have any of that stuff, which means it doesn't get in the way. We're something like 30 instructions from the kit, the interface, to writing on microseconds, 30 microseconds. There's just not a whole lot of overhead there.
So just 30 instructions.
30 microseconds.
Oh, 30 microseconds.
Yes. Of latency through the operating system in the array.
And so is that the part that does the encryption on the fly?
No, we actually do our encryption on the fly in the disk drive. So we work with Seagate, we work with the other disk drive vendors. They all make full disk encryption drives. We work with them at the firmware layer to optimize it for our controllers, and then we do the key management right in the controller. So you don't even need an external PKI infrastructure to manage all of this. Yeah, that's happening right in the disk. So it impacts us, our performance not at all. Pretty cool. I think so. Anyone else? Yeah.
For these storage arrays, typically have they been dedicated towards Splunk, or do these organizations also have other uses for them?
Most often, Splunk is deployed on its own infrastructure.
Okay.
That's the way most people are comfortable doing it. That's the way Splunk will tell you to do it. Splunk does not like having shared infrastructure. We do have some customers who are doing it with shared, usually for smaller implementations, and usually because they already have some hardware there that has unused capacity. But if you're in a greenfield, Splunk will tell you, we want dedicated infrastructure. That's especially true for the storage layer. I've seen a lot of our partners starting to do implementations of Splunk in VMs, not to share, not to do VMs as resource sharing in the server, but just from the manageability that you get from having VMs and being able to move them around the cluster. So you have one VM running on a dedicated server, so it's like they're
By the way, I'll make a question. A lot of customers that I've seen in particular start out with either, like you described, local storage, or their own commoditized storage solution already that's being used a lot of times for traditional IT operations, like a VMware cluster, something along those lines, Oracle databases for storing and bringing them right. And now they're going to go ahead and carve off the segment and give that disk to Splunk so that they have the indexing capacity. And then what winds up happening is over time, security team comes in, now you have data that's coming into a shared architecture, and for security reasons and other reasons, you want to move that data off onto the solution. This is the opportunity where you would look for something along these lines to potentially convert to. Now, my question to you is along the lines of high availability. So if I have a cluster index solution where I'm engaged with multiple indexers, the storage I want to have on multiple solutions or multiple platforms. So from the NetApp approach, so if I'm going through
multiple independent boxes.
yeah.
Yes.
So from an architecture standpoint, would your recommendation that I would need a dual setup of these devices side by side instead of racks, potentially separate data centers?
Would you go back to the hardware slide? I'm really proud as a hardware guy. I only have one hardware slide in the whole. So this is another it depends question. One more, two more. Okay. This is another one of the it depends, right? Because we can put either the low end or the high end controller in either of these enclosures. And, this is the one that's going to get up to, we can do almost a petabyte in it right now. Depending on what kind of performance you need for your indexing and how long you need to keep it, we could put a tray of SSDs in here for the hot warm, and then fill this up with 4 6 terabyte drives for the cold, and do it all inside of one. This is the simple case, not cluster, right? Do it all inside of one chassis under one pair of controllers, so there's no single point of failure in the array. And now if you need to move, when you need to move your warm to your cold, you do it inside the controller. It never goes up to the production network. If your data set will fit in that, and you're doing a cluster and index, you could just have one of these in data center A, one of them in data center B. As you get larger and larger, though, we would eventually outgrow both in required storage capacity and in IOP capacity. We might eventually outgrow this configuration, like at the Wi-Fi provider I showed you, and the very largest of the bundles. What we did in that case was use the all-flash EF560 dedicated for the hot one, and then a separate set of controllers for the 40 drive shelves. And you can chain these out to 4, so you have about 160 drives in one rack. And then just duplicate that into 2 different data centers for your cluster.
And then on your backplate, does that have enough fiber premium so that I can have all my devices having lower LCD and controller? We're going to do it with SAN power switch.
To get the greatest fan out, you would need a SAN switch. For direct attaching, we have 2 different configurations. We have a dual controller configuration where you have 2 of these in the single shelf. Oh, and by the way, these fit right in the shelf, so you don't have to have 2U or 6U just for the controllers. It's very, very compact. But you have 2 controllers right in the shelf, dual wire everything, and you can do 4-to-1, 4 servers to 1 box. Or you can go, if you're willing to take the risk of a single point of failure, and some of our customers are, you go to a single controller wiring with 4 going into 1 controller and 4 going into the other, 9 into 8. If you need fan out even beyond that, you go to a SAN switch.
Thank you.
Yes?
I just noticed that you have your IOPS for reads listed here, but you don't have the rights listed. We know that as well.
Reads. Okay, obviously I stole the slide from somebody else. I would have to look that up.
Because I was just comparing to IO, Fusion IO.
Okay.
And their slowest card is 230, their fastest card is 800, which is not slow, I mean, not faster.
I don't know what if they're measuring reads there either.
They list both. That's why when you compare apples to apples by read, your fastest one is faster than them. They claim that it's 800. Yeah. So that's good, but we can pay for our site server, we're buying, sorry.
Well, the other thing to remember with Fusion IO, to give them their due, it's not just about the IOPS. They're sitting right on the PCI bus, so their latency is going to be even lower. Right?
That's what IOPS is.
No. IOPS is how many individual operations you can do per second versus how long it takes an operation to get through it's the difference between having 30 checkouts at the grocery store, each with 1 person in it, very, very low latency.
So it sounds like the only thing would matter is that with the very first customer, if you can get 800 customers per second, no matter what the second is, you're still servicing 800,000 customers. It's those very first few that you're going to get.
No, because if you're 4 seconds back, you're doing 800,000 customers a second, but you have 2.4 million customers in line, it still takes, your latency is going to be 4 seconds to get through the line. So you're still doing 800,000 per second.
Just the first 4 seconds, and those first four would have to wait. But then once I start putting 800,000, I'm on par with somebody who serviced those first 4 seconds quickly. We're servicing the same number each second.
Right.
So why do I really care about those 4 seconds there? If that really is the difference for the first byte in, first byte out, I think it's very marginal.
It depends on who you are. Some people will never notice it. Some people, this is my favorite story.
Depends on the app too, right? If it's Splunk, it's going to be one thing. So you have an Elasticsearch thing, it's going to be one thing.
Or if it's an OLAP, if it's your, if it's the payment system for your web server. Have you guys ever heard of spread networks?
Like mesh networks.
No, spread networks. It's a company. 3 years ago, they spent an estimated $300 million to drill a hole through the Appalachians to get a straight fiber run from Chicago to New York to cut 3 milliseconds off of their round trip time. Those are guys who care about latency as much as they care about IOPS.
It's the same argument that people have about satellite.
Yeah.
Right? You might get a megabit a second, but if I'm playing a game and I have to wait 2 seconds to see what he did to respond, then I care very much.
Yeah, exactly.
You guys are really not helping my case here.
I like your case because it makes my stuff look better, but I did want to give Fusion IO that did for you. All right, anything else? Am I going to embarrass myself?
There's one.
I'll start over.
There's one potential thing, comparing to internal local. Anybody doing 50 terabytes per node in that one example is not going to do on your, they're going to do one or zero or something. And then the argument about having to rebalance, so you can make it so the Splunk isn't where now your admins are scrambling to replace the failed drive. Right. A lot of failed drives, but I think that's an argument that even in the local scenario.
Which slide was that on?
It was towards the end, something about rebalancing a 50 terabyte node, and I'm like, anybody who's putting that much unmirrored is deserves to wait for the rebalance. Yeah.
The very last slide where I was talking about the 60 terabyte SSDs and yeah. And by the way,
As a system engineer, if I'm building an enterprise system, even if I'm on local disk, which I don't want to do for the management headaches, I'm still going to spend the money, double the number of drives, and have at least RAID monitor for the mirroring so that I don't have a single drive failure causing me to go down. Now, my gap for exposure to second drive failure is huge by comparison to the top.
Yeah.
I think it's a valid point.
And by the way, you do see people doing that with internal drives and servers, you know, having RAID cards or software grade. But you start adding more and more cost in each server, and the advantage of just doing it all on cheap servers starts to erode. Great. Well, thank you, everyone. I appreciate the feedback.
Thank you very much. Looking forward to seeing the presentation again down in .com.
I'm looking forward to your hospitality suite.
On that note, thank you everyone for coming. Just a reminder, we do participate quite a bit in the Slack channel for Splunk Users Group. If you're not a member, email Rachel@splunk.com and she'll set you up with access. It's a great resource for talking to people in the Splunk community. So, anyone else have any questions before we get out tonight?
Can we have a beer?
Yeah. Beer and food in the back. Everyone needs to take one burrito. I'm Sandy, by the way.
Oh, you're